8, that is the topic hazardous waste we are discussing last day. Now in continuation of my 3 lectures of the module 8, that is the hazardous waste. Now today I will deliver the concluding part of my lecture. Now just to some of the things which you have described earlier. Now what are the hazardous waste from the non-specific sources? If you remember, we have defined the hazardous waste from the non-specific sources as well as hazardous waste from the specific sources. So what are the, let us see as a summary that what are the hazardous waste from non-specific sources. Example: solvent waste, electroplating waste, metal treating waste, wood preserving waste, petroleum refining waste. So these are the hazardous waste from non-specific sources. Fine. Let us discuss about the hazardous waste from the specific sources. What are they? Wood preservation, inorganic pigment production, organic chemical production, pesticide production, explosive manufacturing and production, petroleum refining, iron and steel production, primary copper production, ink formulation, secondary lead smelting, cooking products. These are the hazardous waste from the specific sources and so on, because it is not the exclusive list and so on. So some of the major part I have told. Now, we already defined the characteristics like ignitability, flammability, corrosivity. These are the things we have already described earlier. But let us give some example of that. What do you mean by the ignitability? The one of the prime characteristics of the hazardous waste by which we can identify the waste is the hazardous waste. The ignitability waste that pose a fire hazard during routine handling, storage, processing, transport or disposal, because it produces a fire hazard during handling, storage. That means the hazardous waste management. If a solid waste possesses any of the following properties, if a solid waste possesses any of the following properties, what properties? Now less than 24% alcohol by volume and a splash point less than 60 degrees centigrade, then it can be identified as the ignitability characteristics. Again, liquid capable of causing fire through friction under standard temperature and pressure, that will have a characteristics of ignitability. Liquid, if it is an ignitable compressed gas, then also it is an oxidant. It may be ignitable because oxidant means it helps for combustion in presence of oxygen. Examples of the ignitability characteristics hazardous waste, that are the paint thinners are very much ignitability, are falling in the characteristics of ignitability, that is the paint thinners, paint removing compounds, solvents used for cleaning parts and degreasing. So these are the examples I have put for the characteristics under the ignitability. Let us discuss the flammability. Flammability. Let us discuss the flammability. Now, vapors of volatile organic compounds can ignite in the presence of a spark. Lower flammability limit, that is LFL, and upper flammability limit, that is UFL, of mixture. What is the formula? The LFL mixture is 1 by sigma I2N equal to Y1 by LF1. Similarly, UFL mixture equal to 1 by sigma Y1 by LF1, where Y1 equal to mole fraction of compound, N equal to number of compound mixture. We are not going by the mathematical expression, just to as per your syllabus curriculum is concerned, you will be staying in the portion of the characteristic itself, not the numerical part. Now, corrosivity also will be identified by pH value, that is less than equal to either 2.5 or pH value is greater than equal to 2.5. That means the liquids may be the acidic, highly acidic or alkaline, which corrodes steel at a rate greater than 6.35 millimeter per year at a temperature of 55 degrees centigrade. Examples of that corrosivity is the battery acid, phenol waste, acidic waste from metal plating industries. Reactivity. This is the nature of unstable waste. This indicates the unstable waste reacts violently with water. When mixed with water, generates toxic gases. These are the characteristics of reactivity nature. Cyanide or sulfide bearing waste are in the category of reactivity. Cyanide, sulfide can pose sufficient danger to human health or environment. Toxicity. Toxicity characteristics leaching procedure, that is TCLP, toxicity characteristic leaching procedure to stimulate environmental conditions in landfill. Intent of test is to determine whether toxic components of waste could lead to groundwater and soil if exposed to acidic precipitation. Examples: paint waste containing the metals like lead, silver, cadmium, chromium, mercury waste, oily waste, sludge from petroleum industry, waste containing tetrachloroethylene. These are the examples under the toxicity. Now the mixture rule is very interesting. A mixture rule means the amount of hazardous waste and a solid hazardous waste is considered. A mixture of any amount of hazardous waste and a solid hazardous waste is considered hazardous waste. If the mixture, what do you mean by the mixture? That means if a hazardous waste is a mixture of amount of hazardous waste with a solid hazardous waste, mixture of hazardous waste and a solid non-hazardous waste is considered hazardous waste, because that non-hazardous solid waste is mixed with the hazardous waste, so it will ultimately the mixture will become the hazardous waste. So there is also an expectation to these rules, exception to these rules. What is the exception? Exception is if the mixture is hazardous, weighing a particular property, and a resultant mixture does not exhibit this property, then it cannot be categorized as hazardous waste. So the mixture has to exhibit the characteristics of the hazardous waste, then only it can be, the mixture is called the hazardous waste. For example, if paint waste is characterized as hazardous waste due to ignitability, a mixture of paint waste and sand, we know which is non-ignitable, which is non-hazardous. So a mixture of paint and sand would result a non-ignitable mixture, which means that waste mixture can no longer be categorized as hazardous waste. It becomes non-hazardous waste as long as it does not exhibit the ignitability property. So what we have come to the conclusion? We conclusion that the mixture of hazardous and non-hazardous waste can be called hazardous or non-hazardous depending on the characteristics, whether it is the ignitability, corrosivity, flammability, toxicity, like these things which are described under the head of the hazardous waste characteristics. Example, I have told you that the sand, if it is mixed with the paint, that is the hazardous waste, and if it is the mixture, the sand and paint, if it is not found that ignitability, then it will no more called as a hazardous waste. So, if a containment such a phenolic compound leaks from a storage container, which is often seen a problematic phenomena, that a phenolic compound leaks from the storage container into groundwater in the area, the contaminated groundwater is also called a hazardous waste, because the phenol is mixed with water and the characteristics of the mixture will resemble like the hazardous waste. So this applies to any natural material, soil, groundwater. source water incorporated into a hazardous waste. Now, the derived from rule, any solid waste generated from the treatment, storage, disposal of hazardous waste such as sludge, ash, particulate matter, etc. is also considered to be the hazardous waste. Now, I am just skipping the mathematical portion because this is not covered in your syllabus. Now, what do you mean by the solubility? That is the properties of hazardous waste. Let us discuss among the properties of the hazardous waste. Solubility is the extent of the concentration to which a hazardous compound dissolves in a solvent. So, what is the solubility? Now, it is the extent of concentration in milligram per liter to which a hazardous compound dissolves in a solvent. It determines whether the chemical can be found as a separate phase or dissolve. As a separate phase or dissolve. Thus, controlling fate and transport, hydrophobic compounds tend to partition into solids, form emulsions and float at air-water interface or sink to the bottom of aquifer. In general, solubility is inversely proportional to absorption. That is, the more the absorption, less the solubility, less the absorption, more the solubility. So it is inversely proportional to the absorption, bioaccumulation, and volatilization. Partitioning decreases effect of treatability. It is affected by temperature, usually expressed 25 degrees centigrade. At 25 degrees centigrade. Solubility depends on molecular structure, size, forces of attraction. We can generalize by saying that size of inversely proportional to molar volume. As for example, solubility of naphthalene is 32 milligram per liter, while solubility of benzopyrene is 0.00038 milligram per liter. Why? Because the size is inversely proportional to the molar volume. Solubility depends on molar structure. Now, effective solubility. It is true solubility which is defined by the effective solubility of compound in mixture denoted by the SIE, effective. In the mathematical part, I am just escaping the formulation part, I am escaping. Now, the vapor pressure. How to define the vapor pressure? One of the characteristics of the hazardous waste. The vapor pressure of a liquid is the pressure exerted by the liquid at equilibrium. When a liquid is in contact with air, molecules of the liquid leave as vapor and reach an equilibrium. That means rate of volatilization is equal to the rate of molecular dissolving. Whatever the rate of molecular dissolving takes place, it is equal to the rate of volatilization. So this is the law of equilibrium. Now then, fine. Partitioning. Partitioning is a common phenomena in the hazardous waste management that you see from the figure. What I have shown, the source, that is the source of hazardous waste. Now, absorption takes place when the interaction takes place with the soil, the upper portion. If we look at the rightward portion, then the bioconcentration takes place with the biota. The left arrow indicates the solubility takes place in the water, and the volatilization takes place with the air from the hazardous waste source. So, what you can see from the schematic diagram, that is the, I can say, this is the figure. This is the figure showing partitioning. Partitioning means separating. Partitioning of hazardous waste to various media. Media means soil is one media, water is one media, biota is one media, living organism, and the air is one media. So it is partitioning. That means it is separated. The partitioning of hazardous waste in various media is shown in the figure, which I can show you, which I am just showing you, sharing you in my screen, with the soil, water, biota, air in forms of the absorption, solubility, bioconcentration, and the volatilization. Now, so partitioning is the distribution of the chemicals, say hazardous waste, chemicals one of the hazardous waste, between two different media or phases. There are various partitioning coefficients which empirically describe this phenomena. Now, octanol water partitioning coefficient is a measure of how an organic compound partitions between octanol and water. Octanol water partitioning coefficients KOW equal to K octanol by K water. Similarly, soil water partitioning coefficients, that is, water is preferred medium for contaminants. If the contaminant is in aqueous phase, it gets absorbed by soil easily. This is partitioning between the soil and the water. So soil water partitioning coefficient is C soil by C water. Organic carbon content. Organic carbon content, also known as humic coefficient, plays an important role in organic chemical partitioning. It is a fraction of organic carbon present in soil. That means KOC equal to COC divided by C water. Now, contaminants in biota, the partitioning coefficients between biota and water is also known as, see, water is a common because the contaminants are mostly present in water. Now, from water the soil is absorbed, then it will be partitioning into the biota. So, biota and water is also known as bioconcentration factor. So, bioconcentration factor is C biota divided by C water. That means it is an estimate of the amount of the chemical that is likely to accumulate in aqueous organism. The higher the lipid content in an organism, the more is the accumulation. What is biomagnification? Biomagnification is the incremental increase in a contaminant's concentration at each level of the food chain. Again, I am repeating, biomagnification is the incremental increase in a contaminant's concentration at each level of the food chain. This can be explained with the help of the following graphic. See, the food chain, I am just explaining you. The numbers are representative values of the concentration in the tissues of DDT and its derivatives in parts per million. So, biomagnification of DDT. That means in the producers it is 0.04 ppm. Then primary consumers, how it is magnification is being going on. In primary consumers it is 0.23 ppm. Ultimately, consumers are getting magnified. Now in secondary consumers it is further magnified to 2.07 ppm, and finally the tertiary consumers like eagle I have shown, it is 13.8 ppm. So now absorption. Absorption properties of the phase as well as properties of the contaminant affect absorption into soil. You know, the absorption is soil. Absorption controls the rate at which the contaminants move across media. Okay. Now, oxidation reduction potential, it is used to determine the oxidation state of the water, controls concentration of ions present in oxidized or reduced forms, oxidized species, now positive WRP, reduced species, negative WRP. So, These are the what we means oxidation reduction potential. So oxidized species positive oxidation reduction potential, or reduced species means reduced oxidation reduction potential on a relative basis. Now forces controlling absorption, van der Waals attraction force, the electrostatic attraction which is called the adsorption, electrostatic repulsion which is called the desorption, hydrogen bonding, covalent bonds, dipole-dipole interaction, Coulombic forces. Now, hazardous waste management fundamentals. Now, determine the KOC, KD, CS. This example I am just keeping because this is again the mathematical explanation. It is not in your syllabus. So I am skipping that portion. Now, it's very vital that reason for actual solubility in field being much lesser than the theoretical maximum solubility. Now, effective solubility is proportional to the mole fraction of contaminants. So, more the mole fraction, more the solubility, less the mole fraction, less the solubility. Now, other partitioning, there are other kinds of partitioning mechanisms at play here, such as high vapor pressure of contaminants, absorption, and biodegradation. Now, dilution of contaminants in groundwater, how it can happen, that I am trying to show in the figure. I don't know how much it will be visible to you, but I am trying to show the figure how the dilution of contaminants in groundwater takes place. You see the unsaturated zone, that is water table I have shown, lower permeability layer I have shown, solvent migrating in fractures, then direction of groundwater flow, and solvent dissolved in the groundwater flow. So these I have taken from the UK Groundwater Forum, that is the dilution of contamination of groundwater. Now let me tell the mass transfer. Now there are two types of contaminants, mass transfer which takes place, equilibrium mass transfer which reaches the saturation, and rate limited mass transfer when saturation is not reached. Now rate limited mass transfer happens due to limited contact area or time. Lesser contact area results in lesser solubility. Lesser contact time occurs when there is rapid movement of the groundwater and their molecules of contaminants are small in size. This is a figure I am showing you the surfactant monomers and miscellaneous in equilibrium with contaminants molecules and solution interface. Now, what is volatilization? Volatilization is a important characteristics and properties of the hazardous waste. Volatilization refers to the mass transfer of a contaminant from liquid to gaseous phase. This is called the volatilization. So mass transfer, that is partitioning from liquid to the gaseous phase. It is important to monitor the migration of hazardous chemicals from waste sites and storage facilities, both above and below the ground. Now, what are the factors contributing to concentration contaminants in air? The vapor pressure, temperature, mixing, contact area within the storage container, ventilation rate, that is the mixing from outside the room or system, rate limited mass transfer, and dilution will play an important role. You see the performing balance of for volatilization and ventilation rates within a closed room, control room. It is shown by the cubical box. You see ventilation indicated by the arrow left and right, and volatilization takes place by Q, red marked in red. So the ventilation and volatilization flows. A closed room, in a closed room containing hazardous waste. So what is accumulation? Accumulation is flow in minus flow out plus change in the system. Now, fate and transport contaminants in groundwater. So we must describe the advection regarding the fate and transport of contaminants in groundwater. What is advection? The contaminant is physically carried by the medium with the same velocity as the medium. Advection will transport contaminants at different rates in each stratum. Advective flux describing the bulk movement of the fluid carrying contaminants. You see, I have shown you in the schematic diagram how the advection takes place. That is the velocity parabolic profile I have shown, that contaminants left shown by red marked. Now what is diffusion? Diffusion is the process by which a contaminant will move from an area of greater concentration towards an area of lesser concentration. So the contaminants will always have a tendency to move from the greater concentration to the lesser concentration area. That is called the diffusion. The diffusion will occur as long as this gradient exists. That means, so far as the difference in the concentration level of the contaminants, that diffusion will take place. And it will be stopped when there is a difference is in. Now dispersion. Mechanical dispersion consists of two methods. Longitudinal and transverse. Longitudinal dispersion occurs along the direction of flow path, while transverse dispersion occurs normal to the flow path and causes lateral spreading of the contaminants. Now, mechanical dispersion and diffusion combine in groundwater flow to create hydrodynamic dispersion. When the dispersion and diffusion combines, then it will create a hydrodynamic dispersion. Now the process begins when a contaminant enters into the aquifer. Once introduced, the advecting groundwater carries the mass of the contaminant with it, and in the process, the contaminant spreads, thereby decreasing the maximum concentration with time. However, the contaminant is now spread over a much wide area. So this is the dynamic flow, that is the diffusion and the dispersion, how it takes place. I have just tried to explain you, just to give you a hint how these things is happening. Again, I am skipping the numerical mathematical portion because this is not the in your scope of your syllabus. Now, finally, I have come to the conclusion part, that is of the hazardous waste. Finally, that is the transport of contaminant to air. Now, contaminant properties through atmosphere depends on many factors such as fuel properties, wind, and atmospheric turbulence. So these are the factors on which the transport of contaminants to air is dependent. Again, finally, health effects of hazardous waste. A hazardous waste can have adverse health effect in any of the following scenarios. Either a large amount is released at once, a small amount if released intermittently in the same location, that is also equally dangerous to the large amount released at once, because if the small amount is released intermittently in the same place, same location, then that will affect our health. The substance does not get diluted. That means the concentration is not getting decreased. The substance is very toxic, so that will affect our health. And the hazardous waste, uh, having these the four effects, as I told you, this is the adverse health effects is the hazardous waste will produce. Now, humans, plants, and animals can come into contact with hazardous waste by either inhalation, ingestion, or thermal exposure, skin contact. So, exposure can be acute or chronic. Acute exposure, single exposure for short time period. Chronic exposure, that is repeated exposure over long periods of time. Now, what is the example of the acute exposure? Burn on your finger from an acid. This is the one time single exposure, so acute exposure. And leaking downside which results in contaminated groundwater. Health effects including cancer, liver, kidney failure, so physical and mental development. So this is the end of my module 8, that is the hazardous waste. I have described elusively over the different types, characteristics, and how to handle these hazardous waste. Because the characteristics and the properties of the hazardous waste I have also defined many times in my full lectures in module 8. I will definitely upload my lecture notes and video lectures in Google Classroom. Kindly go to the Google Classroom. Definitely after the I will attend the I will conduct the live class for one-to-one interaction session. If you have any queries, any clarification needed, live classroom definitely will meet, and after that I will submit. I will upload in Google Classroom the assignments, MCQ questions for submitting from your part. So thank you for having patience for listening my video lecture. Have a nice day to all.